Hello everyone. This is lecture 37, I believe, and we are in the middle of the tort law. And we have looked at the and get a conclusion that the whether you are using the strict liability or negligence rule, it doesn't matter. Both of them achieve the socially optimal level of precaution. We show that graphically as well as numerically using differentiation. I really hope that would be the end of tort law, but you guessed. Okay, it's not that simple. There are so many complicated real cases and details and modifications, and we are entering that. I wonder if any of you in the previous example wondered. We only talked about the precaution level of the injurer. If it's a car accident, of course the driver should be careful. But then it's not only the driver who can be careful, also the pedestrian who just unlucky enough to be hit by the car, the pedestrian can be careful too. When you're walking on the street, and you just careless or you're careful, a lot of difference can happen. A pickpocket, if you're careless, they will come for you. But if you're so careful, then the probability that you are pickpocketed and your wallet is stolen would be reduced. What about here? If you're walking on the street, you are not, first of all, if you're drunk and you cross the road when it's red or when you are not supposed to cross, then you are more prone to car accident than very sober, like watchful people and who never got drunk, always abide by the traffic signals when they cross the road and things like that. So, in order to make our example realistic, we are going to take into account not only the precaution of injurer, xi, but the precaution of victim, xv. And once again, realistic enough, the probability of accidents depend on not only the precaution of injurer, but also the precaution of the victim. And the new probability function would be 1 over x plus xi, 1 plus xi, 1 plus xv. Okay. If you check if both xi, xv are 0, which means both injurer and victims are extremely careless, then the probability would be 1. That means the accident will happen, certainty. But if xi, xv, or one of them, just one of the xv is extremely careful, then there would be no accident. The value of p is well within between 1 and 0, 0 and 1, so has no problem being a probability. What about social cost? In this case, the social cost is a little bit different because we have xv as well as xi. The cost of wixi plus wvxv, this is the cost of being careful for the injurer, and this is the cost of being careful for the victim. And this is the probability of accident when both injurer and victim are this much careful, and this is the total damage from the accident, combining the injurer's damage and victim's damage. When you talk about the accident, when some car hits someone, obviously the person got injured so much, and compared to that, the car damage is very little, but still the car has a damage. So this A combines both the damage to the victim and the injurer as well. How can we calculate the optimal social level of precaution? Because we have xi and xv now, we cannot do the differentiation worth. We have to do it twice. You differentiate SC with xi, we call that this is like partial differentiation, and you differentiate social cost with xv, another partial differentiation. Because this wv, xv does not have any xi's, we totally ignore. So if you differentiate social cost with xi, it's going to be wi, nothing here, and it's going to be xi here. So differentiate p with xi multiply a. Same for xv. And both should be 0. That is the first order condition, which means that is the way to find out the optimal precaution level for injurer and victim. And if there is precaution level xi and xv that satisfies both these two equations, set 0, then that is the socially optimal precaution level. Now, let's assume that wi, xv are 1. So it's xi plus xv, and this probability here, and a would be 10 power by 6. If you differentiate this, that numerical example with xi, because wi equal 1, it's 1, p would be this, and then we have xi here. This one just stays there, so xv, 1 plus xv stays there, but this one is negative 1, so negative jumps out, and it became 2, power by 2. So if you just consider a little bit, this would be what this means. So the numerical calculation says 1 minus 10 power by 6 over 1 plus xi power by 2, 1 plus xv should be equal to 0. When you do the same thing with xv, differentiate the social cost with xv, then you got this, 1 and 2. And 1 and 2 should be satisfied simultaneously. Then what happened? Because both are 0, 1 should be equal to 0. Then we cancel out 1, we cancel out 10 power by 6. So basically 1 plus xi power by 2 multiply 1 plus xv should be same as 1 plus xi multiply 1 plus xv power by 2. Which means 1 plus xi should be same as 1 plus xv, which means xi should be same as xv in this equation, the 1 and 2. So when we replace 1 plus xv, 1 plus xi, then means 1 plus xi power by 3. Just look at equation 1. Now we find out xi and xv are same, so we change xv as xi. Okay? Then we get this. 1 plus xi power by 3 should be same as 10 power by 6. Okay, I'll give you 1 minute. Think it over. I'm pretty sure you'll understand. Okay. If not, you just go through it one more time, stop the monitor and think it over and scribble by yourself. You will understand this is true. And then this means 1 plus xi should be same as 10 power by 2, which is 100. That's why xi equal 99, but xi should be equal to xv. So xi, xv should be equal to 99 in our example. Okay, this is how you calculate the optimal level of injurer's precaution and victim's precaution. Of course, it's potential victims and potential injurers because the accident hasn't happened yet. when in the case of bilateral precaution is necessary, which means not only the injurer, not only the driver, but also the victim, also the pedestrians should be careful, okay? Which is more realistic than our previous example where only the injurer should be careful. Okay, so we found out the optimal level of precaution as long as society is concerned. Can you see the pattern? Like we find out the optimal precaution level as a society, social cost. Then we check strict liability. What would be the result? Would it be same as the socially optimal precaution level? And negligence rule, would it be same as the socially optimal precaution level and the negligence rules precaution level? Okay? Hope that I'm not too fast. But then, because it's online recorded lecture, you can go over again. I know this is complicated, so I hope you can go through it over and over again by yourself and make it yourself, your own. Okay, bilateral precaution. We still in the middle of bilateral precaution level. And think about strict liability. Strict liability means here, once again, if there's an accident, who is responsible for all the damages? A, it's the injurer. So I'm a car driver, Professor Han is driving car, hit Jim, and then they would never ask, oh, Jim is hurt, there's harm, and Professor Han caused it. That's the only thing needed for strict liability. So Professor Han should pay everything, the hospital fee and everything for Jim. I say, oh, I was slow. Jim jumps out. Jim was drunk, lying on the street. And then I was very careful. He was so careless. On the strict liability rule, they do not listen to you. Okay? So from Jim, the victim's point of view, the only cost is WVXV because the victim is not responsible at all about A. So this is the individual cost of injurer and victim. What's the difference? The strict liability means this whole part, including the damage from accident A, cost of accident A, should belong to injurer, not at all to the victim. That is the spirit of strict liability. In that case, what is the easiest one? The victim. The victim, injurer, whoever it is, want to minimize its cost. When your cost is WVXV, always positive, and as X increases, you're more careful the cost increase. And you want to minimize it. How can you do that? You set it 0. Of course, if your precaution can get to negative, but we'll stick to the positive and 0 number. So the smallest possible precaution level is 0. And at that time, the cost of victim would be 0. Cost would be minimized. So naturally, the victim will choose 0. XV equals 0. Already, it's not optimal. Go back. The XI, XV should be 99. That is socially optimal level. But then, as soon as we enter strict liability, the victim automatically immediately set XV as 0. Therefore, when the injurer minimizes this, injurer is not stupid. He knows what victim would do. The victim XV would be 0. So the injurer, when it calculates to minimize its cost, it is not, he would be stupid if he does not set XV equals 0, because obviously the victim would not be careful at all. So he minimized WIXI plus probability where the XV is 0 multiply A. In our example, let's go back. When XV equals 0, this whole thing would be 1 and disappear. So basically it would be 1 over 1 plus Xi. Why? Because XV would be 0. So I wrote here 1 plus Xi because XV would be 0 and 1 plus XV would be just 1. So this would be the cost of injury when victim is totally careless, XV equals 0. If you differentiate it, it will be 1 equal to this. Once again, this is negative 1 jumps out equals 0 and things like that. Okay, 1 minus something equals 0 and minus something I move to the right hand side and this is that. Okie dokie. So if you calculating it, 1 plus xi power by 2 would be same as 10 power by 6, which means 1 plus xi would be 10 power by 3, 1000. So xi, 1 plus xi is 1000, xi is 999. Is it optimal? No. We show that xi should be 99 in order to be socially optimal, but it's 999, much bigger than the social optimal 99. So when both party, injurer and victim, should be careful, bilateral precaution case is needed. Bilateral precautions are needed. If we just simply apply strict liability, then the victim's precaution level would be much smaller, 0 against 99, much smaller than optimal level, and the injurer's precaution level is much higher than the optimal precaution, which is 999. So we have obviously inefficient result under strict liability. So the rule is not good enough. Okay, strict liability make the victim less than optimal careful and make the injurer more than optimal too careful. Okay, so it cannot be socially optimal. Okay, I showed you with just one simple example with a specific WI, WV, and P function, but you understand why this can be easily generalized. When two people should be careful, one person is totally careless, the other party should be extremely too careful to balance that. Okay, and in both ways, it's not efficient. Okay, very important. You have to go through this. What about negligence under bilateral precaution case? The A here, the damage from the accident, the cost of accident, belong to the injurer if the injurer is less than optimal precautious. You are driving 60 kilometers per hour when the rule said it's 50 kilometers per hour, so that your carefulness 60 kilometers per hour is less than 50 kilometers per hour carefulness. Okay, the speed is opposite to that. Faster means less careful. Okay, so then injurer get the whole responsible for the whole A. But if the injurer's carefulness this is a I, xi is bigger than or equal to the optimal level xi star, then the government say, injurer, you don't have to pay anything. The victim, as a result, victim have to pay everything A. In this case, the injurer obviously would choose 99 because if you choose like 98, 97, if there's an accident, you are responsible. You don't want to do that. If you go over 99, now you don't have to pay, but you don't have any reason to be careful like 100, 203 because 99, you don't want to be too careful, but this is just enough make you free of any responsibility on A. So you have no reason to be more careful than 99. So now the victim can understand that. Victim assume that the injurer would choose 99. As a result, 1 plus xi would be 1 plus 99, 100. So xv plus this. And because 100, 10 power by 2, 10 power by 6, we cancel out. It's 10 power by 4. So the cost, individual cost of victim would be xv, because wx I assume as a 1, xv plus 10 power by 4 over 1 plus xv. Okay, very simple arithmetic. And you want to minimize your cost by differentiating xv. You set it 0, then this would turn out to be 1 minus this equals 0. Because 1 plus xv power by 2 should be same as 10 power by 4, 1 plus xv should be same as 10 power by 2. Cancel each out. So 1 plus xv should be 100 and xv should be 99, which happen to be, once again, the social optimal level of precaution we calculated here. Socially optimal calculation, xv should be 99, and under negligence rule, the victim choose the precaution level of 99. Oh, then we remember the injurer choose the precaution level of 99. So basically, in this negligence rule, the injurer would follow the guideline of the government who says, oh, if your precaution level is under 99, you would be charged heavily when there's an accident. I don't want that. So I would barely free of that A because I don't want to be extremely careful. That is costly too. So xi star should be 99 by the negligence rule. And once that is accepted by the victim calculate the minimal to minimize his cost or her cost. The choice would be same as optimal. So in the strict liability, the victim choose the xv as 0, not optimal. As a result, the injurer would choose its xi as 999, which is much bigger than the optimal 99. So there was inefficiency. But here, the injurer choose 99. As a result, after calculation, the victim choose 99, which is socially optimal. So here we understand that when only the injurer should be careful in the previous lecture, it doesn't matter whether we have strict liability or negligence rule. Both achieve the socially optimal level of precaution. However, in this case of bilateral precaution where both the injurer and victim should be careful, it's very critical. The strict liability can never give you the optimal level. On the other hand, negligence can. Another maybe twist I want you to think by yourself is, what if the negligence applied to the victim? So like the victim is liable if xv is smaller than xv star. Injurer is responsible when xv is bigger than or equal to x. So we change injurer and victim and xi, xv here. All change all xi to xv's here. That is also negligence. But the negligence in first example applied to injurer, but we can apply the negligence to the victim. If the pedestrian was not drunk, abide by the traffic signal and everything, then still there's an accident. I don't care whether you are speeding or not, but the victim was careful enough. So it's the driver's fault. Still, I'm sure that if you calculate it, the xi, xv at the time would be optimal again. So the negligence rule is far better performing and achieving the efficient result when it's the bilateral precaution case. So negligence rule is superior than the strict liability. Okay, this is not end. We have much more to talk about the total law and this kind of calculation. Please think about, if you don't understand it correctly, please listen to the lecture again, because this is very important and complicated part of total law. See you in the next lecture. Thank you. This has been a lecture 37, I think, 37, and we are in the middle of week 12.